Okay, I think everybody is here. We're going to go ahead and get started right at 12 o'clock. Thank you very much for joining us today for the TAB and Clean Room Testing webinar. We are fortunate enough to have Patrick Law with us to present on this topic. A couple of things I would like to cover. If you joined us yesterday for our very first webinar, then you already know the drill, but for those that weren't able to participate yesterday, I'll just tell you a little bit. We want to make this as interactive as possible, so we suggest and are encouraging you to please ask questions throughout the presentation. Pat is going to take the questions and field them as they come, and then of course we will have a Q&A at the end of the session also. To submit your question, there is a Q&A section in Zoom that you can just type out your question and then I can present that, or you can raise your hand and we will unmute you and allow you to be able to go live and ask your question. So whichever avenue you are comfortable with is fine with us. Also, we, in an effort to uphold the integrity of the CECs that we will be issuing for this webinar, there will be various questions that are asked throughout the presentation. It will flash up on the screen, ask you a question. There'll be answers to choose from. We ask that you submit your answer. The poll will be up for about 45 to 60 seconds. I kind of monitor how many responses we get. So please be sure and participate in that. And we will be verifying those responses with, the accuracy. So try to answer them to the best of your ability. And all of the questions are coming from Pat's presentation. So at this time, I would like to introduce Patrick Law. He's been testing and certifying clean rooms for the past 30 years. Pat joined the NEBB family of professionals shortly after the first clean room procedural standards was published. He has been developing curriculum, practical exams, and teaching at NEBB seminars for the past 20 years. Pat has led NEB's clean room discipline as a past clean room committee chair and also currently serves on several NEBB committees, including NEBB's board of directors. Patrick, welcome. Thank you again for taking the time out of your day to join us. And I will turn it over to you.
All right. Thank you. Am I audible here?
Yes, sir.
All right, good. So listen, my motivation when I first thought about this, was, as a clean room testing certifier, we always come behind the tab. They have to more likely done their work before we come in. And we've had some issues and we thought, boy, it'd be nice to know that, a way to bridge the gap a little bit between our two disciplines. There's a lot of similarities in what we do, but there's some things that maybe help you when if you do have to do a tab, test and balance or something on a clean room, maybe this will help you, give you a little bit of insight. So that was the motivation. All right, so the first thing is that I thought that you should know is that your work's gonna be checked. If you did the work and another NEB firm is gonna come back, especially if it's a clean room, make sure that work was done. You do it, you're testing the same way on the entire job site, whether it's taking volumes, with or without maybe the, using the damper, the compensation damper and say the one hood. They understand that HEPAs are fragile. Report any damage that might happen to them during any of your testing. And I've seen some things that have really, happened in the past that have really made that, there's maybe a little bit of misunderstanding, but HEPAs are a little bit fragile and they have to be sealed properly and working properly to do their job. And our clean room testing from a standpoint does not get started until the tab is completed. And a lot of times, quick reporting is essential. If it's completed, we can start some of the testing, but it's nice to be able to have that final report done as well. So probably having a quick reporting response is somewhat essential. And they have here another point, the HEPA's airflows have volume limits. just registers. Sometimes the size of the register dictates the volume that is designed for. HEPA filters are no different. They only allow a certain amount of volume to go through them to be working properly. Tab expectations, when you go to the job, the same job we're going to go to, is the rooms are properly, when you're done, that the rooms are properly balanced. You make adjustments to airflow, the supply, returns, makeups are made to set the design. The hydronics are set, motor amps, volts, RPMs are all recorded, and pressures are read across the fan mostly. I mean, maybe in some cases you get into the room and look at the pressures there as well, but generally most tab jobs, I don't know that you guys do the pressures from room to room or even particular rooms to outside the building or such, but that becomes a big part of what we do. But your job is completed and you report your final readings. From a clean room standpoint, is that the tab is complete. Various multiple clean room tests are conducted in a sequence. Results are evaluated for acceptance. And out of compliance, adjustments are made either by us or maybe others. And a lot of times this goes back to the tab technician. If something needs to be adjusted for one reason or another, retest to verify compliance. Final results are done and a certification is issued. And then here for us, documentation becomes extremely important in a lot of the fields we deal with. It seems to rule everything they do. Briefly, types of clean rooms that are out there. You have a unidirectional, and unidirectional usually means roughly that 80% of the room is supplied, it's got media coverage in it, not necessarily the frames. That's taking the frames out and stuff, but the media itself where the air enters the room. But 80% of usually the ceiling, sometimes it give you a wall, but of that clean room will have 80% media coverage where the airflow is flowing in at 80% of the ceiling. Non-unidirectional type of clean room. This could be anywhere from having HEPAs scattered throughout to having just a few, to having 50% or 60%, doesn't matter. As long as you don't have 80%, you're not unidirectional. Membrane clean rooms are a type of clean room we don't see much anymore, but I thought they were very, and can be very effective in what they do. A membrane ceiling will have HEPA filters that enter into a small space that's now confined below the ceiling, and you have to put a membrane and it's just something that repressurizes that small enclosure, and then therefore directs the airflow evenly across that whole room, as opposed to just at the points where the HEPA filters are in the ceiling. Give you an example, if you took your supply air diffusers, your basically 24 by 24 supply air diffusers, and came below them and put another, say maybe 18 inches to 2 feet below them and put another ceiling. If it was tall, if you had a 10-foot ceiling, drop it down to 8 foot, you put a membrane in there that covers the entire room, but lets air through it. What happens is those supply air diffusers will pressurize that space, and then the airflow will distribute within that room, kind of like a piston, and go, if the returns are at the floor, to go from the ceiling all the way down to the floor in a somewhat uniform manner because of that membrane that's put in there. Vertical, which is typical from the ceiling down to the floor, or you have horizontal flow clean rooms, and this where you may have a portion of the wall or entire wall possibly that has HEPA filters, and but the returns now will be on the opposite wall. They won't be in the floors necessarily or in the ceilings. They'll be on the opposite wall. So again, the horizontal clean room supplies at one side and then moves to the other side of the room. So where it's the cleanest, right next to the HEPA filters, and probably less clean, picking up contamination on the way to the returns. Same as going from the ceiling down to the floor, but this just goes horizontally rather than vertically. You have recirculating type clean rooms with makeup air, most common that are out there. You do have single pass, which is 100% outside air. You don't see an awful lot of those, but they do exist for a lot of good reasons. You'll see those in a lot of pharmaceutical medical device, where again, the supply air could come to these rooms, and we're talking air changes in the maybe 200 air changes per hour or greater in some cases, that none of that air is recirculated whatsoever. You got 100% outside air comes in. You're having to cool that outside air and bring it into the room and control pressures and everything else with that. So that is a beast that has its problems, you know, in controlling. Low wall returns, which is fairly typical. Type of clean room, again, ceiling HEPA filters and then low wall returns. And then you have floor returns, which a lot of the microelectronics will have, again, HEPAs at the ceiling. And in a lot of cases, unidirectional flow clean rooms, which, maybe the entire ceiling is covered with HEPA filters. And so that all the airflow has got to exit somewhere. Rather than having low wall returns, the floor itself has got holes in it. It's a venting floor, and you can adjust them just like you can adjust a damper. So you will have, and this is to get the air going in a straight pattern rather than maybe coming down and going to the left or the right to the returns. It'll go all the way through the floor as it enters the clean room and exits in an extremely straight manner. So, which is, highly desirable in a lot of cases, especially in the, where the microelectronics is the critical nature of what they produce in their clean rooms are much greater than you find in even a pharmaceutical medical device, because the particles that contaminate the equipment are much smaller than the particles that the FDA is worried about inside of a drug manufacturer, for instance. Clean room styles, you have terminal HEPA filters. They can be ducted, which is, again, the most common. You'll have either 10 or 12-inch ducts that run off a fan, a duct run or something. You do have filter fan units. We call them FFUs, but we do have filter fan units that will have its own onboard motor blower. And the HEPA filter, again, typical 24 by 48, same as ducted HEPA filters. Their typical size are 24 by 48. You'll have some 24/24s on the fan filter units as well, or even some larger ones now. But these filter fan units all have an onboard motor blower. And so generally what happens is you have a space above the clean room, an interstitial space above a clean room that has a bunch of these terminal HEPAs that are filter fan units. And that may get its air conditioning. They don't provide any conditioned air. All they do is recirculate the air. So you have to bring conditioned air into that same space from your main AHU, which gets done. And then the return. So you have a mixture of these filter fan units that are pressing or supplying the air changes that might be required for that particular clean room. You don't need as big a fan other than the cooling capacity to help cool that space. And then these terminal HEPAs also can either be disposable, which meaning they're sealed, and when it goes bad, you take the next one off and you unclamp it from the duct run and put a new one in. They're pretty easy to do. Again, fairly common, but becoming more common now are what they call room side removable. And again, they can be an FFU, or they can be just a ducted terminal, and it ducts into a housing that allows you, rather than having to push that HEPA up, unclamp the tie strap that's connecting the flex duct to the 10 or 12-inch duct collar. That stays permanent in the room side removal, and then you just unclamp the filter from the room side and replace it. It's much easier, a little bit more expensive, but it's yet another method. The other thing that you lose from room side removable filters is the amount of media area. It's significantly reduced because of the extra framing needed to house the frame that's holding that filter in. HEPA banks inside an air handler unit that uses supplier diffusers in a room. That's another style of clean room that, usually you see these in clean rooms that are like maybe ISO 7 or ISO 8, and we'll talk about these ISO classes in a minute, but they're the least clean of the clean rooms out there. But they can still be effective for certain clean rooms, and it works like that. But you may have a bank of a few HEPAs, or you might have a bank of a huge amount of HEPAs. And they can, I can tell you, I did a job that had 29,000 CFN air handlers that all converged to one single duct, that, and in each one of these had, I think, maybe 30 to 36 HEPAs a piece in them that were, to handle that kind of a volume. So these are something that have to be dealt with from time to time and understanding. So HEPA banks and air handling units that use in these spider diffusers. Another style is positive pressure ceilings. This is when you may have a channel. You'll have a channel that's put up instead of a T-grid that you lay in tiles or lay in, registers in, or even HEPA filters in. This will be a permanent structure that will have made in such a way that it receives HEPA filters that have a gel in them. They'll either have a track that you fill with gel and special filters that go down into this gel that do the seal, which is effective if it works properly. But in the scope of how these work for us in the industry, they cause more problems than they actually solve. In theory, they're a good idea, but every little thing, when you have a positive pressure ceiling, let me go back a minute. With clean rooms, what we try to do exclusively is keep contamination out of the clean room the best we can. And you do that, again, by having the HEPA filters not be leak-free, or however they're installed not leak. And so when you have these positive pressure ceilings, they cause potential leaks inside the clean room, because the clean room itself now becomes negative to the interstitial space. Unlike a ducted HEPA filter, that's all done, that clean room is now positive to the interstitial space, which is what we prefer. The other one requires so much great sealing, and it's very difficult to do, so it doesn't work that often. Even HEPA banks are very hard to seal, like you can seal terminal HEPA filters. They don't work as well as most people think they should, and they really don't. The recirculating plenum with the AC used as a makeup, I explained that with a lot with the FFUs. That's kind of what we're talking about, is a plenum that has returns to go up to these FFUs, and your AC is brought in as a makeup and for the cooling, conditioning of the air. And then you do have rooms that 100% exhaust as well, which has its own issues. So industry regulating industries, you have pharmaceutical medical device that go on FDA guidelines and a couple others. You have compound pharmacy. Now, again, a lot of hospitals, they follow guideline USP 797, and every hospital does any kind of compound pharmacy in it, which is almost every single one of them has got to have, a clean room installed in it now and working properly. So there's a lot of potential there. And this is somewhat new. This is probably new in the last, I think, maybe 10, 15 years. So they're still trying to learn what's needed, required, and such. But is an industry that, because there's so many hospitals across the nation, and the tab, you're going to find yourself in a lot of hospitals. There's a lot of work that can be done in there and understanding what's needed in there, because you do have some positive and negative pressure rooms that are required in a 797 facility, and that's in every hospital that does compound pharmacy. Hospitals, your operating rooms, will sometimes have HEPA filters and clean rooms in them. And again, it may be a wall of them, or it may be above them. It could be, I've seen both. Isolation rooms sometimes have, maybe some filtration and such, other than just, limiting the pressurization. Bone marrow rooms, I've seen those where, again, right up against the headboard, you have a whole bank of HEPA filters, because the immunity of people getting a bone marrow transplant, I guess, is almost nil to nothing. So they got to keep out as much contamination as they can when that person's, having that done. So these bone marrow rooms will have HEPA filter banks in them as well, horizontal rooms. Other industries, microelectronics, aerospace, food industry, but basically anywhere that contamination is detriment to the product yield or failure. It could be an auto bag, contact lenses, even eyeglasses. Listen, a quick story. I had a job where I was called in because this manufacturer of, they were reading glasses is actually what they were, but they were, their product yield was 70%, was all they're getting from the manufacturing. They were throwing out 30% of their product because of contamination. And so they had us come in and say, listen, we have HEPA filter, we have these little mini environments for all our glass manufacturing, and we're not getting, can you just test us and help us out here? So I went in testing and during, even during operating conditions, and I found the air to be, believe it or not, fairly clean. And I was like, wow, I mean, this is not going to be good news for them that they're having so much failure. But, you know, the instrumentation is telling me that the air is relatively clean in this room, or at least at the time I was testing it. However, when I walked in these rooms, these little mini environments, all the glasses that didn't go through or whatever, this thing spit out more stuff, and it was all glass was on the floor everywhere, on the shelf. And this was so filthy and dirty. It's just the airflow alone was pulling up the stuff that was, because they never cleaned it. And when I confronted them about it, they said, well, yeah, no, we go run 24/7 and we don't stop. I said, you've got to add in a, you know, I don't care, one a day, an hour a day to stop that presses and clean it. Your product yield will go up a lot, you know, because the air, you know, in general is clean. It's doing its job. At least the one I tested seems to be doing its job. You know, so it's just a matter of it's picking up all these extra particles that are becoming in the environment because of the airflow being as great as it is and nothing being cleaned. And they reported back to me 2 weeks later that they had, you know, just by doing this, and I think they did it once a week, they had increased their product yield by another 15%. So other industries do use clean rooms and HEPA filters to do their stuff.
Pat, can I stop you right there and let me launch this poll, please?
And
Just a few more seconds on the poll. Okay, thank you.
all righty. So clean room priorities. First of all, our biggest priority in any clean room is our classification. You know, all the other tests that are conducted inside a clean room are there to help us meet our cleanliness classification. That's our, you know, the ISO classes 1 through 9 and such. Clean air changes is another priority we have, not return air changes or outside air changes. You know, we have a priority pressures over supply air. And I say that because I've been in behind jobs that get done and the pressures are not right. However, the supply air, you know, might be exactly as it was designed to be. Hey, you know, and that's, I think, the priority that probably happens with a tab technician or tab professional is you go in and you gonna make sure and you set your supply and probably didn't go and set your return and make sure your makeup, you know, your turn your makeup equals your supply. That's, you know, that proportion's outright. But if that prevents you from making the pressures where they are, then as far as a clean room owner, the pressures take priority over the supply air. If the supply air is a little less in a room, but it creates the pressure required, that is a higher priority for a clean room to operate than, and the clean room owner would rather operate in that condition than having the supplier be, well, listen, it calls for exactly this much and I've got you exactly that much. Yeah, you're not quite pressures, and so I can't do anything else than that. But it may mean you have to adjust your air so that you pressures are the come in compliance.
Hey, Pat, can I stop you right there? We have a question.
Sure.
Is it acceptable for a clean room hood certifier to use a piece of cardboard to block off a portion of the hood in lieu of having the correct sized skirt on their hood?
No, that's not the way it should be done. the back pressure that you get from putting any kind of hood up there is going to have some effect on that. And no, you really, even putting a piece of cardboard up there is going to create enough back pressure that's not going to give you your true CFM. So no, it is important that the hood that you use match the airflow device that you're pulling. Now, let me go back. If you have a supply air diffuser, you could have one that covers that and a little bit more, or even more, and it's not going to affect the airflow. But you can't have one that's smaller than the airflow that you're measuring. And you don't want to overlap and do more than one at a time.
Okay, I have one more question. This individual says, are they talking about a biological safety cabinet?
Yeah, that may be, that is taught in, you usually have a small, in a biological safety cabinet, you do a negative, then you actually use a hood in the reverse, and they have them that are made for biological safety cabinets to do that. And they do call for blanking off part of that to, because they don't have one that fits every size, but yeah, you can blank off a small portion of that. It's usually an 8 or 10 inch opening, and your flow hood should be the majority of that. And if it doesn't reach to the end of it, yeah, you can, take a little bit of that off. But that would be the only time that it would be. But you don't want to use a real small one and blank off half of it either. You're still going to lose a little bit because of that back pressure.
Okay, thank you.
So we're talking about clean room priorities here. Velocity versus volume a lot of times. Not all the time, but again, if it's a unidirectional flow room, we're going to take velocities on that. We're not so worried about the volume there, but the uniformity of that velocity. Hence the second point, uniformity of the airflow. That's important. Airflow is used to dilute and remove particles, and that's why these are up there. They don't bring any in. They're just used to help dilute and remove particles to keep an environment that is to a particular level. And it may not be 100% particle free, but it's got to meet certain, conditions of particles or certain requirements of particles, per cubic foot or cubic meter. Average room velocity or work plane velocities usually can be just calculated. They're not measured as easy as calculated. I think we're changing that. In clean room testing, we have 4 mandatory tests that are conducted. We get the airflows, which you guys do already, room pressures, differentials. Now we look at room pressure differentials, but you guys know how to take room pressures. So that's something you know how to do already. HEPA filter leak testing, that's probably out of your ballpark if you haven't done that. And cleanliness classification. And that's, again, if you have never done that, it's a little bit to get caught up on how to do that. But if you look at that, most of the tests that are done in clean rooms and the 4 mandatory tests that are done, you guys know half of those already, how to conduct half of those. And you may have to look at specifics on airflows because there are some differences on that. But still, it's the instrumentation and most everything else with it is pretty similar to what you already know. Here's the other secondary optional test that we do is airflow parallelism, airflow visualization, which is similar to that. Temperature, humidity, sound, vibration, recovery, lighting, electrostatic, EMI, and conductivity, floor conductivity. That EMI is electromagnetic interference. And again, the electrostatic, EMI, and floor conductivity, again, are found in mostly the semiconductor, where it's very critical to their process, or more critical to their process. Test methodology, again, major difference between our 2 disciplines is that TAB uses one source. When you look at how am I supposed to go out there and do a test and balance on this project, as a NEB technician or professional. Your one source is the NEB procedural standards on testing and balancing. And there's not been a whole lot of major changes to that technology, to that methodology rather, probably in the last 50 years plus that NEB's been in the industry or been in existence. However, clean rooms, we have multiple sources and choices. It's always evolving, and audits and justifications always seem to be evolving the standards that which we do by to test and certify clean room, unlike what TAB's had to do in the past or currently do.
Pat, I have 2 questions, if I
Sure.
could pause you for just a moment.
Sure.
The first one is there a certification for performing DOP testing, dispersed oil particulate testing?
Ask that again.
Is there a certification for performing DOP, dispersed oil particulate testing?
And there was something else. Well, we have our technician, a NEB clean room technician. This is part of what's on that exam. There's, you're examined on that. And again, as a professional, there's questions on that particular test. So it's not a separate just for DOP leak testing. It's included in when you get tested as a technician or even as a professional, we don't just test you on what you know already, say the 2 airflows and the whatever, but you're tested on the whole gamut, including the secondary testing. But the secondary testing doesn't have as much weight as the 4 mandatory tests. So when I would say that you've already know how to do pressures and airflows, you've already learned 2 of the skills required, of the major skills required. The other 2 are not as difficult. And then, in learning some of the other optional tests, again, there's a lot in that information, but like I said, they don't weigh as much on the exams because of our, body knowledge. We looked at that, and since they're not done as often, they don't have as much weight. So there's not as many questions on these secondary things like that. I don't know if that answers it, but all in all, you get tested on everything, whether you're doing, as a clean room technician or a clean room professional.
Okay. Yeah, I think that answered it. If not, the individual can ask additional question. One other question. From a clean room design standpoint, how do you calculate the amount of net supply airflow to a room in order to keep it at, say, 0.04 in INWG?
It's his water gauge
Pressure with respect to adjacent spaces. What about when you have, for example, 3 rooms end to end and the pressures have to cascade?
That's a long question. So listen, it almost sounds like this is something for the design engineer. I mean, I don't know that you can, is what we do. And listen, I can probably still get you there a little bit, but what we do is we basically go and test and verify. We don't design the clean room to work properly. There's clean room designers that say, this is how the clean room ought to work. Here's how the pressures ought to work. And here's how here's the design for that and what we did design the airflows and everything to meet this. So when I put so much design airflow in this room and I look at what's going to be exhausted out of that room or what's maybe returned air in that room, what kind of makeup I need, all that's calculated out from an engineer, a design engineer at the beginning. And then we go in and verify, is it doing the job that it was designed to do? I don't know if that answers the question, but
I think that's fine. We can always follow up with, because it is a very long and specific question, but we can follow up with that if that doesn't answer the individual's question. And then I just received one more certification for testing HEPA filter testing.
Right. That sounds like the same question. There's not a specific certification for just leak testing.
So it's just a part of the clean room.
It's part of the technician program and part of the professional program.
Okay.
For clean rooms. So now there's training. Listen. As soon as we get the clean room finished, and that done on the training at the NEB in Gaithersburg, that'll open up and there'll be training on actually how to do leak testing and such. So that's a big plus. It's something going down the road.
Okay. And before you get started, let me just launch this poll real quick so we don't have to bother you.
Okay.
Okay, we're going to close the poll. Okay, thank you, Patrick.
All righty. So, all right, let me, listen, I realize this, I got to tell you something. I realize that this presentation is probably going to take a little bit longer. So I'll try to speed through this so we can get through it by 1 o'clock here. And we'll see what we do here. So anyways, for clean rooms, our test methodology, we have 4 different documents. Like I said, TAB's got the one. We have 4 major ones that we look at. And of course, NEB's procedural standards on clean room testing and certification. IEST, which is the Institute of Environmental Sciences and Technology. They've been around for many, many years. It's, you know, we use that to help write ours. But they have an RPCC 006, which is a recommended practice, contamination control 006 and 034. That has most of the tests in it, everything except for particle counting. And that's where we now yield to ISO, which is the International Organization for Standardization, 14644 parts 1, 2, and 3. And then another one, because a lot of what we deal with here in the US, we sell to other countries and a lot to Europe. And therefore we have to follow EU guideline, Annex 1 of EU guideline. And in a lot of our clients, because they fall under their jurisdiction just as much as they fall under our FDA. And there are other minor clean room test documents, including our owner SOPs. And so there's always a choice of which method to use. So a lot of times when someone says it quotes a job, you know, you may have to specify how am I going to test this? Which document do you want me to use? You know, as far as my quote, because they might be different. Airflows, like I said, volumes or velocity, we have to make that decision in a lot of the cases, what we do. Like I said, what's important, pressures over supply, clean air changes is, again, you know, these, what's coming in through the HEPA filters is the most important. And velocity, uniformity, and ISO 5 or better. That's really important for us. And when it comes to airflows, and then other considerations, uniformity of airflows, even when we don't have, you know, a lot of filters in that room, to keep the distribution of temperature and such across the room, they still have to be balanced just like HEPA filters would be if they were in a big, say, 80% ceiling coverage. And again, airflow is used to elute and remove particles. Air exchanges, a little bit differences here. Nominal air changes is the amount of outside air ventilation from one air handler entering a building or zone, but it does not include recirculation air or the distribution of the ventilation air to each space within a zone. Unlike, again, space air changes, which is what we deal with, and what's important to a clean room is to calculate these space air changes, but because it compares the supply airflow rate to that volume of the space that you're testing. Air changes per hour comparison. There's another slide here. This one's a little bit better slide than that one, but this will give you the, and I didn't talk about this yet, but up at the top here, if you can see this, the ISO classes, we have ISO class 1 through 9, and these are the air change range. As you can see, an ISO 1, which is the cleanest, and this would be an ISO 9 would be the dirtiest. But here in an ISO class 1 clean room, we're looking anywhere from 360 to 600 air changes per hour for, say, class ISO 1 or 2. Most pharmaceuticals are going to have an ISO 5, but this is the range, 240 to 480 air changes per hour, and it drops down from there, you know, significantly. So those are our typical air changes when we talk the space air changes, clean air changes that have to be done in order to maintain this continued cleanliness within that space. It requires that many air changes in order to keep it clean. Airflow volumes done are very similar to TAB, best done at the same time. A lot of times we may have to, do we use back pressure on this? Do we not? Curtain size, as I said, that was one of the questions that came up, but yeah, the curtain size should always match your register filter size or whatever else you're measuring there. And what we do a lot of times is if we like to check ours against a TAB. If we don't, because sometimes we'll be on a facility where TAB's still doing TAB work in another part of the building that doesn't affect the clean room. And so they may still be on site, but they may have completed the clean room or whatever. And sometimes we'll get with the TAB people and say, hey, what are you doing? How are you doing? And we'll compare our flow hood to their flow hood, and maybe put a factor in that if we need be. Because I'm telling you, if you haven't done this already, every flow hood does not read the same. You can go get 10 short ridges calibrated, put them on 10 different flow hoods, and they're all going to read a little bit different. And that's just the technology of the equipment and the plus and minuses out of these equipment. They're not perfect. So we do try to get, so our report doesn't look significantly different than the other report. If there's a change between the hood they use and the hood we're using, we put that adjustment to it. And we just make sure there's not an issue with it, but we'll make that adjustment, just so you know.
Hey, Pat, we had a question about the chart that you showed, I think, a slide or two ago. What ISO standard is the chart from?
Well, this typical air change chart is not from a standard. This was this is just typical. Somebody put this together. I'm not really sure, but there's no industry standard out there that says in order to have an ISO class 3 clean room, it has to meet 360, a minimum of 360, greater than 540 air changes, like that chart shows. This is just a recommendation, and it really is what's been a part of clean rooms and for, the past 75 years probably. This is what we found to be, or the industry has found to be the needed air changes in order to meet these classifications. There's not a standard that says you have to have that.
Thank you.
Velocity instruments, varied types of instrument, electronic micromanometer or micromanometer with a tube array or single point, thermal anemometer, maybe. Different methodology, distance from the HEPA filter or a single or multiple point, when you're using these things. Hey, do I use a single point of this one? Do I have to use a multiple point? How many inches do I got to be down, or how many? Listen, it all gets a little bit different. Some of the concerns is the location of readings, reproducibility by technician, and the repeatability of the readings. And that repeatability might be from time to time. We go back every 6 months on a lot of our jobs, and we want to be able to repeat the same methodology and the same thing and get relatively the same cause and answer. So, it's important for us to make sure that we can repeat these readings when we go back 6 months from now. Even reproducibility between the technician, from one to the next or within the same one, they've got to be able to get that same reading over and over and over again. And so we try to do these so that we have the readings that we need that are repeatable and reliable. I'm going to go this real quick. Listen, let me back up here. Listen, a single point uses in our standard and most standards out there, not all of them, believe it or not, requires that on a typical 2x4 HEPA filter, you're going to do grids of 1 square foot, minimum grids of 1 square foot. So you would have a total of 8 readings on a 2x4 typical HEPA filter. If you're using a multiple point, it says do 1 per every 4 square foot. And most of these multiple, and these two animations that came up on that have to do with the 16-point bell grid that you find on a short ridge, which is used a lot. And some of the others have something similar. But if you notice, there's 2 different ways that this could be applied, and you get 2 different results. And notice the pattern that it actually takes of the filter, and you will get different results depending on how you take it. So my point is, take it the same way all the time. And then if you document how you took it, then when we come back, if we have to do it, then we have that same. I'm going through this one to get it out of the way. Variation, going to get it out of the way here. Not important. Unidirectional, where do you take the readings? Again, like I said, there's multiple standards out there that we have to deal with. IEST says no more than 12 inches from the face of the filter. ISO says 6 to 12 inches. NEB says take it at 6 inches. So we have 3 standards, that say it a little bit differently. But all of them, you can take it at 6 inches and you would meet the requirement. So that's something you have to look at and say, hey, it meets IEST. Yes, it's between there. Okay, it meets them all. Non-unidirectional, a little different. Again, no more than 6 inches now from IEST rather than to 12 inches. Again, ISO's the same and NEB's the same. Considerations, you document your test method when taking direct velocity readings, how far away you were, how did you, if you're doing a multiple point, how did you orientate it? So that again, it can be done again. Again, when taking volumes, hood curtain should match the filter frame. Adjustments often use the case of V factor to calculate, and it adjusts velocity readings when a flow hood won't fit over the equipment due to interference. Again, I know you've been to sites where you have this, where you're taking readings, but they put a piece of equipment under the supply air diffuser and you can't get a hood up there or whatever. So what do? Now, a supply air diffuser is a little bit different than a HEPA filter. The HEPA filter is still going to exit airflow out, and coming down, but I can't get the flow hood up there. So we have to use our velocity at that point and then come up with a K sub E factor to adjust that velocity to meet what it actually is meant, or what the actual volume might be. In the industry, we recognize as the flow hood for, first of all, if I'm not speaking out of there, that the appeal tube, which we don't really use that much to measure airflow anymore, airflow velocity or volume, but other than in large ductwork sometimes. But that is the most, if you have the correct ideal conditions in that your duct diameters are right and you have enough upstream and downstream of where you've done your holes in and you're taking your readings, if that is done in a perfect condition, then a pitot tube is going to give you a most accurate result. After that, your flow hood is going to give you the second most accurate result. And then thirdly is going to be velocity instrument. And that, again, will change depending on how far down or close you are to the HEPA filter, how that air is exiting that HEPA filter and such will sometimes dictate how far you can be from that as well. So there is a need for this K factor saying that, hey, we don't trust the velocity as being the most accurate. We feel the flow hood is, I can't get a flow hood on this one, so what am I going to do? So we come up with a K sub E factor in order to do that. And again, very briefly, because I think it's important for you to know that you would choose random filters, multiple filters, 3 or 4 maybe in a room. And then you can read the velocity. These are filters that are unobstructed, that you can read with a flow hood and velocity as well. So you would read both the velocity and the volumes on that hood and read the velocity and volumes multiple times on each of those, say, 4 filters. And then you would average those results and then calculate a correction K sub E factor. And this is a little bit more detailed going into that. I'm going to get past that. That's the formula for the correction factor, which is basically the correction factor is the quantity of the volume of airflow actual, what you got with the flow hood. And I took 5 readings, I averaged 5 readings, this is my average volume. All right, this is what I'm gonna say the volume of that filter is right now, right? And then from the media area, that's easy to measure and calculate. And then the V sub M is your velocity measured. This is what you can do with your other device. You can measure the velocity that you'd say is maybe not as accurate as the flow hood. So, and then you come up with a K sub E factor that you will now, when you use the velocity instrument to read that velocity underneath the HEPA filter where you can't get the hood, you would now apply that K sub E factor times that velocity in order to get a corrected volume. That's what that's for. Example, I'm going to get off an example here for you to move along. An acceptance criteria for that. All right. Relative standard deviation when it comes to airflow. And that's simply the standard deviation of velocities or volumes divided by the average velocity or volume of those same filters that you tested. And in our industry, the relative standard deviation, almost everything we do has to be less than 50%. So whether we take volumes or whether we take velocities in a room with unidirectional flow, this relative standard deviation must be 15% or less. So that's another thing, again, when you're going out there testing, that's how important it is even in rooms that don't have, that you get these volumes closer together. Room pressures, most interested in differential pressure between room versus the ambient. The range of differential pressures range from 0.02 inches to 0.07 inch water gauge. And the hierarchy always depend on the classification. You will always have your pressurization start at your ISO 1, if that exists in that clean room suite, to a 2, to a 3, and so on, all the way down to a 9, or to your uncontrolled area. Just so you know, I've never, and I've talked to a lot of people in the industry, this ISO 9 is a new classification that came out. And to my knowledge, I don't know anybody that's ever used it. It is so, it's not even a clean room. It's hard to even say it's a controlled environment. It's so outrageous at the number of, particles that are allowed in that environment that we don't even know why there is an ISO 9. But from ISO general range right now, we go from 1 to 8. So you would have your pressurization cascade from the highest or the lowest cleanliness class ISO 1, if there is, or 2 or 3, whatever that lowest number is, out to the uncontrolled, through 8 to an uncontrolled area. A lot of times we take pressure drops on the HEPA filters in the room and record that at new and watch that over time to see what the decay is, so we can give an idea when it's time to change them if they're not doing their job. All right, room pressure differentials perform after the clean room has been balanced. The airflow volume or velocity test has been done. The airflow parallelism test, if you're doing that's done. The airflow visualization test has been done, and all penetrations are sealed. Prior to conducting the test, there are several transient conditions that affect the room pressures: intermediate operation of exhaust hoods, wet stations, ovens, etc. Again, we find tons of those in these, clean rooms. There may be fume hoods in there. It could be biological safety cameras. There's a lot of exhaust of some of the equipment that's in there because of the heat. It gets exhausted out. So again, as you know, that affects pressure. So when we test, we got to make sure that these things are operating. We know what the, or if there's any kind of actuating damper that's controlling. If this exhaust, do we up the volume in our makeup air to compensate that and such. So all this needs to be working and operating. Wind loads, listen, that's, I haven't seen that an awful lot. I'm not going to, I had one case of it I was going to talk about. I'm moving on. Conducting the test, electronic manometer, room pressures. I don't think I need, and this was, I had this, I'm going to take this off, talking about real briefly, but looking at, here's, if we had a pressure difference between all these 5 rooms, we can actually, without measuring for what it is from A to outside of E, so to the outside uncontrolled environment, if I want to know what the pressure was from A to, like I said, outside, I can actually measure or calculate that up by adding those pressures together, which adds up to 0.206. So, and likewise, I can calculate pressures between different zones if I know all the pressures of each zone. Just by adding, or maybe even here subtracting, where I have now a negative. I got room that's negative to something, but the same way, if I add these all up using that one as a negative, I get my, from A to the outside is now changed. But I likewise can still recalculate different pressures. And I know I'm going through this fast a little bit. This I'm not going to, this is, I added some rooms and talked about this, but we're getting on that. And this, another pressure, we're going off that. All right. Acceptance criteria, again, for us, typical pressures for the guidelines that are out there. And then you won't find a standard on this, but you'll find a lot of guidelines that the FDA's got a guideline on, hey, this is what ought to be. In the industry, usually will have their own SOPs to say, hey, the pressure between this room and this room has got to be this much, or between this and area and that area has got to be so much. But typically it's 0.02 inches to 0.06 inches when cascading from one class to a space of another class, or 0.04 to 0.07 when you're going from a controlled to an uncontrolled. This might walk into the first, it could be an airlock. You may walk from a hallway that's uncontrolled into an airlock, and that airlock into a gown room, and so you would have these different barriers that you get into, and the pressure from that airlock to that uncontrolled, again, is going to be higher than it is from the different rooms within the clean room suite. Temperature, humidity, duct diversity we talked about. Leak testing, again, we talked about that. So this is, that's a typical raised floor clean room where you have some kind of a fan that's supplying and maybe a whole ceiling coverage going down to the floor, so that any contamination that's released at the product level gets down and washed out right away, rather than going side to side to the sidewall returns where it might have the chance of cross-contaminating. Listen, if you're bidding a clean room job, reach out to a NEB certified professional. They can probably help you and get, some of the few surprises that are costly or otherwise when bidding or performing a job. But a clean room certifier and company can be a good sounding board for that. And my conclusion after all this is, when balancing clean room facility, if the tab contractor has a better understanding of what will take place after they have completed their balancing and what is expected from the owner, It will only help to ensure a greater chance of having a successful outcome when the clean room is turned over to the owner. That's my presentation. Thank you for your attention.
Thank you very much, Pat. At this time, we will take questions. We were kind of holding off on questions so that he would have an opportunity to finish his presentation. Are there any questions at this time? Okay, we're going to take one more poll. Let's see. Just a few more just a few more seconds here to respond to the poll. Okay, thank you. One more call for any questions that you might have for Pat to address while we're on the call. Certainly, if you have any questions that you think about later or want some additional information about, we can get that information to Pat, and I'm sure he will be glad to.
Absolutely.
All right, Pat. Well, we don't have any additional questions. Thank you very much for being with us. For everybody that is on the call, I know that it's a little bit inconvenient, but it is how it is set up so that one was a webinar and one is going to be an actual Zoom call where we can see you. So you will need to log off of this webinar and then log back into the annual meeting link, which is actually a Zoom meeting. So we will see everybody there shortly. Thank you.